Let's start with question number 10. Now, this question belongs to section of electromagnetism. Here, a magnet of total magnetic moment 10 to the power minus 2 along x-axis is placed in time varying magnetic field, which is also along x-axis but varying as B cos omega t. The value of B is given as 1 Tesla, that is the maximum magnetic field, and the omega is 0.125 radian per second. The work done for reversing the direction of magnetic moment at t equals to 1 second we have to find out. Let's start with the solution. So, we'll follow the energy method here. So, the initial, that is the ui, will be written as minus mb cos of omega t, that is 0.125 into 1, and the final potential energy would be plus mb cos of 0.125 into 1, right? So, starting from here, if you want to understand that what is the work done, it would be simply u final minus u initial. Solving this, you will get twice of mb cos of 0.125. Thus, when you put down the values, so this is 2, this is 10 to the power minus 2 into 1 into cos of 0.125. On solving, you will get work done as 0.0198 joules, right? Let's see which is the best option here. So, among these, none of the option is matching. So, I hope this will be given to you as a bonus. Let's move ahead and start our next question. So, question number 11. This question is from waves and basically the topic is Doppler effect. Here, the train moves towards the stationary observer with a speed of 34 meter per second. The train sounds a whistle of its frequency registered by the observer as f1. So, this is the apparent frequency, this is not the actual frequency. If the speed of the train is reduced to 17 meter per second, then the frequency of registered is f2. So, this is the new apparent frequency. If speed of sound is 340 meter per second, then find the ratio of f1 and f2. It's very easy and formula based question. Let's see how we can solve this. So, the relation between the apparent frequency and the real frequency for this will be v, velocity of sound wave, plus minus velocity of observer by v plus minus velocity of source, right? Now, as for the first case is concerned, f1 is equals to f0, velocity of sound wave is 340, and observer is stationary and train is moving towards the observer. That means here you will be writing 0, and since the train is moving towards the observer, it would be a case of 340 minus 34, right? Similarly, in the next case f2, the original frequency would be f0. Again the observer is at rest, so it is 0, and this would be 340 minus 17. Now just we have to take the ratio of f1 to f2, then simply we have to divide this as equation 1. Let's take this as equation 2, dividing 1 by 2. What you get here is f1 by f2, f0 would be cancelled, and it would be 340 minus 34, 340 minus 17, right? When you solve this one, you will get equal to 19 by 18. Let's see which is the best suited option here. From the 4 options given, option number 4 is the right answer to this question, right? So, let's see question number 12. Now, in here you can see this question belongs to segment of electromagnetism and chapter would be current electricity. So, as per the question, in the given circuit, the cells have 0 internal resistance, both the cells. The currents passing through resistance R1 and R2 are respectively. Simply the current has been asked. So, I'll take here that I1 current is being supplied by this battery and I2 current is being supplied by this battery. And together here the current would be I1 plus I2. And whatever current has been given by the battery, that will be returned to it. So, I2 will come back, right? Let's take this as point P, this as Q, this is X, this as Y, this as Z, and this is at M, right? Now, we have to solve this by the help of Kirchhoff's law. So, let's make some equations. taking consideration of loop P, M, Z, Q, I'll get as, starting from this point, I'll get 20 I1 plus I2 minus 10 is equals to 0. Solving this, I'll get I1 plus I2 would be equal to 1 by 2. This is equation 1. Now let's take this loop Q, X, Y, Z. With the loop of Q, X, Y, Z, you start from this point here and you move in this direction. So from here to here there is no potential drop. From here, when you see the current is moving down, so it would be plus 20 into I2, this would be minus 10. When you reach up, it would be plus 20 into I1 plus I2 and you will reach this point again. So I'll say 20 I2, this one, then minus 10 plus 20 into I1 plus I2, that should be 0. Solving this, you will get 20 I2 plus 20 I1 plus 20 I2 is equals to 10, or 20 I1 plus 40 I2 is equals to 10, or I1 plus 2 I2 is equals to half. This is the second equation. So with the two equations of this, solving this, you will get from 1 and 2, you will get I1 as 0.5 ampere and I2 as 0 ampere, right? Let's see which is the best suited option. So from the 4 options given here, option 3 is the right answer to this question, right? Let's move ahead and see question number 13 in the next section.